All right, now let's go ahead and get started on setting up a job in Vcarve. So what we want to do first is go to create a new file, and we're going to look at the job setup over here. So there's the job type, single-sided, double-sided, or rotary. We're only going to be covering how to deal with single-sided jobs here. So select single-sided jobs. Next up, you want to select your job size. Two ways to kind of go about this. One, you could enter just the size of the sheet of material that you intend to cut. So if you had a 2 foot by 2 foot piece of material, you could put in 24 by 24. Another option, which is the way I prefer to do it, is to always set up a job for a 96 by 48 inch sheet that gives you the entire working area of the bed on the ShopBot in the event that, say, one corner of the machine has a little bit more wear and damage on the table and you want to use a different side. So that's why I always go with the 96 by 48 full size setup. What I do want to point out here is that 96 inches is going to be our x-axis length. So make sure that you're setting up your jobs in landscape mode where 96, the long axis, is along that x-axis. So if you're switching to millimeters, you can do that as well. It doesn't automatically do that conversion though, so just be aware that you have to convert 96 inches into millimeters. All right, getting down to the next part here. Actually, let's look at Z, or thickness. So thickness is going to be the thickness of the material that you intend to cut. Whenever we're using a ShopBot, it's very important that we get the thickness measurement correct, because if you put it in as a little taller than what the material actually is, you run the risk of cutting all the way through the material and into the table of the machine. So in this example, let's say we're working with 3/4 inch plywood. We'll want to set this number to something probably around 0.7. Now, most plywood actually comes in somewhere around 0.7 rather than 0.75 when you're looking at 3/4 inch plywood. Now, with that said, it's always important to just go ahead and measure that material when you get it with a pair of calipers. There's calipers that are available in the wood shop and in other various places around the M-Hub shop. So just go ahead and measure your material thickness correctly. So going off of that, what we're looking at here is our Z0 position. So for every axis the machine has, it needs to have a reference point. So for X and Y, the default reference point is this corner of the machine, which corresponds with, the corner of the machine where the computer is sitting if you're actually in the room with the ShopBot. So that sets your X and Y 0 right here at this corner. Now Z0 has to be set by you, the user. And you can choose whether you want to set it at either the surface of the material you're going to be cutting or the surface of the machine that your material is going to be sitting on. Now there are advantages to both of these, but it can become a little bit more risky when you're using material surface as far as setting depths and making sure that you don't run into the table of the machine. So if you reference the material surface, that basically means you're going to say that the top of your material that you're cutting on is 0. So all of your cuts are going to be below the 0 point. So everything is going to be negative. So all of your Z values will then be negative. Now, what that means is that if you are cutting all the way through the material, you need to be very, very accurate with this number here as far as the material thickness, because if you, say, have half-inch material and you had put in 0.7, then it's going to cut 0.2 of an inch into the machine bed, and that is definitely not good. So we want to avoid doing that. So just make sure, there's nothing wrong with selecting material surface. Just make sure it becomes very critically important that you set your Z thickness accurately. Now, you can also use the machine bed, or rather the spoil board. By doing that, you're setting the bottom of all of your cuts. So the good news there is if the machine already knows where the bottom of the material is, it can't go negative of that, or not without you telling it to do so. So that way, you'll always know where the bottom of your material is, so you can come all the way down to that point. The problem, though, of course, is, again, if you are very concerned about having accurate pocket depths or partial cuts into your material, it'll be slightly less accurate in that sense. Now, again, all of that can be solved with just making sure you have that material thickness set correctly. So just want to point those two things out. As far as this XY datum position, this is default to this corner here, this bottom left-hand corner. That's going to be standard. We'll leave it as that. Beyond that, we have our modeling resolution down here. Modeling resolution is basically how many pixels are in the preview. I strongly recommend setting it to very high, otherwise it is very difficult to see what is going on when you run your preview. As far as this appearance, it's purely what color the preview is going to look like and has nothing to do with what material you actually intend to cut. All right, let's talk a little bit about some of the drawing tools in here. So this is kind of your pretty standard set of drawing tools here. We have circles, squares, rectangles, all that fun stuff. But just some kind of interesting things to note. There are tools such as this one here, which is bitmap tracing. This allows you to bring in something like a JPEG image and turn it into vector files that can be cut. This is also a pretty useful thing if you want to laser cut JPEGs. You can actually export DXF files, vector files, from this software that you traced off JPEG images, so that's kind of neat. Something else to note is you can go and import vector geometry. So if you prefer to work in Illustrator or AutoCAD or a CAD design software like SolidWorks or Fusion, you can do that as well. So if we go to File, you have the option to import vectors, and you can see what different vector types are available here. So a lot of different options there. Now, something to note is when you bring in a vector, you want to make sure you do have closed line work. I'm going to intentionally make some unclosed line work here, and you'll see what I mean by that in a second. So what we have here is a triangle. However, you'll notice that each of these individual sides is selectable. That's not what you want to see. You want all of them to be selected at one time whenever you click on it. That indicates closed geometry. This program has a pretty simple command for doing that. All you got to do is select your geometry that you wish to close. Then you just go down here to Join Open Vectors, just that little icon right there. Click on that guy. It'll give you a tolerance, so if your lines are not perfectly sitting on top of each other, it will pull them together if they're, closer than 4/10,000ths of an inch. So you can even see right here, it says there's currently selected vectors, there's 3 open, and after doing this, we will have 1 closed. So just click Join. Simple as that. Now we have our closed piece of geometry. Another thing to note is when we are just using the standard drawing tools, you can either draw by just clicking and dragging. I've created a square there, or a rectangle, but let's say I did want to make it a square and I wanted to know exactly where this corner right here is. So I could say that corner is at 12 by 13, so x12, y13, and you'll see it will actually move that piece. Now I could reference the middle or any of the other corners. Another option I got here is I can actually set the size of it. So if I wanted it to be a 10 inch by 10 inch square, I could set that. And you'll see that will actually just modify the shape itself. So it is nice for drawing accurately, just to kind of sketch something together in a pinch. Some other cool tools that are of use, or at least I find pretty useful. We have the fillet tool here for rounding corners, but you can also make dog bone and T-bone style joints. These are mainly used when you're doing joinery and you need to fit a squared corner into another part. This allows you to actually bump that corner in all the way to the corner, because you cannot cut sharp square interior corners with a round bit. So just something to be aware of. Now, another thing you can use this for too is simulating what your part's going to look like at the end if you're cutting something out. So you could say if you're using a 1/2 inch tool, you can set your tool radius to 0.25. And you'll see here, whoops, that was the dog bone style. Let's go with normal fillet, and you can see, there we go. So now we can just get an idea of just what that corner is actually going to look like if we were trying to, pocket out this object here. All right. Lastly, I'll just point out a couple other tools. Again, we got nesting. So if you have a bunch of parts, letters, or otherwise that you want to get out of a single sheet of material, you can use this nesting tool to try and get them to automatically fit all within that area. There's also snipping tool for cutting off loose ends if you have a line sticking off past another one. Your move commands, so if you want to just move any parts around. There's also mirror and rotate parts, as well as scale. So just kind of your basic drawing related tools. And again, you can import vector files of your own if you need to do that, or again, prefer working in an alternate program.